We're at the Vroom Passive House, and here on the south side of the house, we see a much larger overhang. And in fact, not only is it longer, but it's also much taller. The lumber is 6 inches as opposed to the other side where it's 4. The structural engineer did design for this, and he in fact did give us this great layout of the structural lumber that's sitting on top of the roof and the overhang and how we make sure that this is strong enough. Here's the problem. Is when he did this, he didn't take into consideration the load that this would place on the inside framing. And the design of this house calls for really great open web floor truss of 18 inches in diameter where we can run all of our mechanicals, all of our electrical, and all of our plumbing. The problem is the house started getting high enough where it was approaching the maximum elevation that the house can be on the land from the ground to the very top, and that number is given to us by the city. And the city says this house can be no taller than 28 feet from the bottom to the top. And the problem is the architect wanted to keep the roof diaphragm, the TJIs or the rafters, as thin as possible. And so they chose a 9.5-inch rafter here. Now here's the problem, is that's a 17-foot span with a 9.5-inch rafter with a lot of lumber and insulation and another layer of material and the roofing material on top of that. And secondly, the architect didn't understand that we needed a plywood base underneath the standing seam roof. She had sleepers, and those sleepers did not give the waterproofing and the standing seam metal enough support for any of our roofers to be comfortable putting the standing seam over essentially board and battens. And so what we had to do is overlay this whole roof with plywood. Now here's the problem. Is those 9.5-inch joists, those rafters, are not strong enough to do that 17-inch span without a lot of deflection, meaning they go like this. Now, the architect wanted to keep that roof thin, but the engineer didn't understand that a 1-inch deflection of that roof would change how that roof looked, because up top of the house, you can actually see along that roof and you could see the deflection. And we don't even have all the materials on top. When we get all the materials on top, that's going to be a lot more deflection. So now we have to actually put more lumber in the roof to make it stronger so that it can deal with all the additional loads. This was a breakdown in communication with the architect and the engineer, with the engineer not understanding that 1-inch deflection would change the ceiling height in that vaulted space right above the kitchen. And that would not be appreciated by the clients. And the architect didn't understand the requirements for the metal roofing and didn't put in the right materials there so that the roofers would actually install their roofing material. We had a breakdown of communication on a lot of parties here, with people not understanding what was expected, not understanding the tolerances, and now we have to do something to fix all of that way after we should have had that designed into the structural engineering plans the first time. Again, structural engineers need to be aware of the expectations of the project, and they need to do the calculations. And if a 1-inch deflection over 17 feet is too much, more than 1 inch is definitely going to be too much. If you're interested in learning more about building science, about building a better way, hit subscribe as we show you how to build a better way.